สวัสดีครับ In this clip, we will discuss the solution of the test number 3, which is still on the problem of motion in one dimension. Here, the frog hopper, some biological name, is supposedly to the best jumper in the animal kingdom. To start a jump, this insect can accelerate at 4 km per second over a distance of 2 millimeters as it strengthens its specially adapted jumping leg. Assume the acceleration is constant. How high would the insect jump if air resistance were negligible? Okay, so in this problem, this frog, this animal, can jump with some special mechanism. It can stretch its leg to accelerate itself with a very high acceleration, 4 km per second square. And then after when it finishes this mechanism, it will gain some initial velocity. Okay, it will gain some initial velocity, and then it jump up. Here it means that we assume it's jump in the vertical direction, and we want to calculate the height of this frog. So what we have to calculate first is the initial velocity, and then after the first step, we finish the first step, and then we calculate how the frog move vertically under the gravitational acceleration to the maximum height. Okay, I think this is some typo. It should be centimeter. Okay, so first step, we want to calculate the initial velocity. Okay, we want to calculate the initial velocity. In the problem, it say that the frog can produce the acceleration during the mechanism of strengthening its leg, and it gained the acceleration of 4 km per second square over the motion of 2 millimeters. Okay. Here again, you can see that we don't want to know the information of time. We just want to know the information of the final velocity when the frog start this mechanism. And final velocity of this mechanism will be the initial velocity of the frog when it moves vertically under the gravitational acceleration. Okay, so we assume that the acceleration is a constant, so we can use the formula for the motion under constant acceleration. V square equal to V0 square plus 2ax minus x0. Okay, here we know that V0 is equal to 0, right? Because the frog is initially in the first step. The frog is initially at rest, and then it starts the mechanism of strengthening its leg, and then accelerate with the 4 km per second square to gain the initial velocity. So the frog starts from 0 velocity, and then what we want to know is the v, the value of v. Okay, and we have A is equal to 4 kilometers per second. Now it is a 4 kilometers per second, okay, which we can convert into meter per second. So we have this 4,000 meter per second square, not per second, sorry. Okay, and the distance, which is the distance that is stated is red, is 2 millimeter, which we also can convert it into 0.002 meter. Okay, here we convert all the unit to be the base unit of the SI unit, so it is easy. When we move on after this mechanism, we can calculate the maximum height. Okay. Now we have that v square is equal to 0 square, right, plus 2 of 4,000 times 0.002, okay, which equal to 16 meter per second square, meter square per second square, okay, right, because 4,000 times 0.002 is 8, and 8 times 2 is 16. So we have the initial velocity is 16 meters per second, which is quite high. Oh no, not initial velocity, the initial velocity square. Or we know that we have the initial velocity at the 4 meters per second. Okay. Now, the second step, that after this mechanism finished, now the frog move freely under the gravitational acceleration. Okay. Again, we don't care about the information of time. We want to know the information of the maximum height. So we know that at the maximum height, we find out is equal to 0. Okay, and now we have A equal to minus G. Okay, because here if we choose the upper direction, upper direction as a positive direction. Okay, upward direction, not upper, sorry, upward direction as a positive direction, and the gravitational acceleration point downward. So we have the acceleration after the initial mechanism. Okay, we have to separate two parts: the initial mechanism and after that the frog move freely under the gravitational acceleration. So we have Vf equal to 0 and A equal to minus G. Again, we use this relation Vf square equal to V square plus U A x minus x0. And we know that Vf is 0 at the maximum height. The velocity is 0. And V square is what we just calculated, is 16, which equal to 2 times minus G, which is the minus 9 part 8 meter per second square. So this is a minus 9.8, not plus 8, 9.8. Okay, and x minus x0 is the distance that the frog moves. So we can change the variable to be h, which is the height of the jump. Okay, so we have the height is equal to minus 16 over 2 times minus 9.8. okay, which you can use the calculator. 16 over 2 times 9.8, which equal to 0.816 meter, which if we convert into centimeter, it is 81.6 centimeter. Okay, and we have the solution 81.6. Answer is number 4.